Right, so thank you everyone. Good morning, good afternoon, and good evening. Let me start by thanking the event organizer and Prof. Slim for organizing this interesting event, and I'm sure it will be an interesting discussion about technology and connecting the world and bridging the digital divide. My name is Laith Hamad. I'm a regulatory engineer. I work with OneWeb and I cover Middle East and Africa. And I'm here to present OneWeb as a company, and we will discuss how the future of satellite connectivity as we see it from a new technology perspective. So I'll start with my. I usually start with this presentation. It is just to show how big the problem of connectivity it is in the world. So more than half of the population of the world are unconnected, are not connected to the internet. They don't have access connectivity by any means of communication, and 20% of the fixed broadband connections is less than 10 megabit per second. So this is, of course, as you know, it's not reliable or fast enough to meet the growing demands of the internet, broadband hungry applications, if we would say. And there are more than two-thirds or 77% of enterprises, of course, are in this growing demand, and they are moving for and changing to computer infrastructure, their computer infrastructure into the cloud. So all of this developments and demand worldwide would require innovation in technology in order to bridge the digital divide, in order to make sure that these new technologies can make connectivity available to everyone. So when I say everyone, of course, we mean at home, at offices, when you are flying, at sea, everywhere. So, so I'll speak about OneWeb in a glance. At a glance, as you pretty much aware, OneWeb has gone into a bankruptcy protection process, and this is in the U.S. Under U.S. Bankruptcy Code, Chapter 11, is to protect OneWeb because, as you know, many of the companies worldwide has been affected by the pandemic, and COVID-19 has just came, I would say, in a wrong timing for OneWeb, because we are very close to close our financing until we finish building the network and start providing services. However, due to the market crash, stock crash, and all the pandemic effect on the world, OneWeb ran out of money, and we had to go under bankruptcy protection. So the Chapter 11 process is a long process. We have pretty much came a long way, but we are still in the process. The good news that we have been acquired by the UK, by Her Majesty Government, and by Bharati Group. Bharati Group, as you may know, is the third largest mobile operator in the world. They have more than 400 million subscribers. And we have interest from Hughes as well to invest in OneWeb. So those new owners of the company has invested more than 1 billion. And as a result of that, we will emerge from Chapter 11 very soon, I would say, before the end of the year. The bankruptcy court has approved the plan, the emergence plan of OneWeb on February the 2nd, on October the 2nd. So that's a few weeks ago. And we are now on our way to emerging from Chapter 11. We still need some or few regulatory approvals. and we will be out of it. So that's a very good news, and we will be back hitting the road, manufacturing satellites, building ground stations, launching satellites in order to build the network. So OneWeb use a total of 6 gigahertz of a spectrum, a combined spectrum in Ku and Ka band. We will speak about this in this presentation. The difference of OneWeb and its technology, the low Earth orbit technology, LEO, is of course the low latency, which could provide, and as a result, the type of application it could support. And the last point that we will discuss in this presentation about responsible space. So this is a planet we all live in, and we have to make sure that we keep it for our next generations. It's the space is one space. If we keep launching thousands of satellites and we make space debris, it will definitely not be sustainable. So I'll speak about I will speak about how OneWeb is supporting space, a responsible space, and how we contribute to the debris discussion and regulation around the world. So despite COVID-19 and the pandemic and the result of OneWeb going into bankruptcy, we are still on track to become the first provider of a global coverage. And when I say global, that means every inch on the world will be covered by OneWeb satellites from pole to pole. Our constellation is a polar orbit, low Earth orbit. From pole to pole, we have 12 planes with several satellites per plane. We'll speak about this in a bit, but as a general overview about OneWeb, we have done 3 successful launches in February 19, February 2020, and March 2020. So a total of 74 satellites. And the production of our satellites have never been stopped, by the way, in our factory in Florida. We are ramping up again in order to hit or to manufacture 2 satellites per day. So that's in order to meet the demand of a rapid launching and meeting the schedule milestone. And then on the ground, we are underway building 13 sites around the world out of more than 40 sites. Those are gateways, which we call a satellite network portal, where the data will land on the ground, and this point will be the link between the satellites and the ground. So we have TT&C, telemetry track and control station. We have GNOC, and we have an operation center around operation centers around the world, as well as those gateways around the globe. So let's speak about the technology of low Earth orbit and what is the competitive advantage out of that. So if we look into the slides, so we have those 3 types of satellites orbits: the geostationary orbit, which is the typical orbit for current satellites, or most of the satellites in our life these days. So those are at 36,000 kilometers above the Earth. And the problem with this very far distance is, of course, the latency. And this is, as you know, pure physics. It's just the distance signal travels at a speed of light. So as a result, we have like 500 or 600 millisecond latency, and that, of course, does not support all of the internet applications, especially those applications that requires a low latency. So we have, for example, at the bottom of the slide, if we're speaking about gaming, it requires almost a real-time interaction, and that's less than 100 millisecond. And then for other application like voice over LTE, it needs at least 150 milliseconds or below 150 milliseconds. And then the cloud applications, it needs less than 200 milliseconds. So those are the difference between orbits. If you go closer and closer to the Earth, then you have a lower latency. And the closer you become to the Earth, the better coverage you have, and a better latency, of course. So in the low Earth orbit, there are a few proposed LEO constellations: OneWeb, SpaceX, Amazon, Telesat, Kepler. So those are some or most of the constellation proposed in the low Earth orbit. So so we'll speak about this competitive advantage. So particularly for OneWeb, we will be going to launch like 600 low Earth orbit satellites. It will use Ku and Ka bands, as we will speak in a bit in those slides. We have a very good or very low latency, and particularly a very good look angle, especially in those parts of the world in the north or south or near the poles, where the signal of the geostationary satellites will be a very low angle. So in OneWeb, the satellites will be always vertically above you. So that's a better look angle, definitely. So what is different about OneWeb and its technology is the coverage, the pole-to-pole coverage. It is cost-effective solution because we are producing satellites of the mass production. And this lowers the cost. Each satellite costs $1 million compared to geo satellites where you need millions of dollars to manufacture. We have a very good partnership with the blue chip industry. We work with many of the very well-known technology providers, using them in our gateways, in our user terminals, in our satellite bus and payload. So that's combination of technology combined together in the space segment, in the ground segment, and in between, if we could say, what is making OneWeb different. And of course, not to forget the unique spectrum position of OneWeb. So OneWeb has a very good priority in Ku and Ka band, and that's by the International Telecommunication Union regulations or radio regulations, which is like first come, first serve. If you apply or you file first for the spectrum, then you have a priority. And then everyone comes after you have to protect you. And then, of course, you have to protect your or the older filings ahead of you. So OneWeb network serves land, sea, and air. This is a rough presentation about how the system works. We will go through it in detail. So we have the satellites connected to a user terminal, whether at land, sea, or on aircraft. The traffic will go through the satellite to the gateways, and it will be controlled by the telemetry and control stations and by the operation center. And it will be connected for a point of a presence for the internet feed. And of course, then it will be connected to the customers and the internet cloud. The market verticals is basically everywhere and everything: enterprise, maritime, aviation, government, and as well as cellular backhaul. So cellular backhaul is particularly important for OneWeb because it allows the mobile operators to extend their coverage and enhance their services, where laying down fiber is not commercially feasible, or using point-to-point microwave is also maybe not commercially visible, or not, or the terrain of the ground does not allow such installation. So a cellular backhaul the OneWeb services which support a cellular backhaul will extend the mobile operator coverage so they can provide their services to their users. And by the way, the OneWeb system is fully standardized as per the latest release of 3GPP. So 3G, LTE, and in the future, 5G. So it's like a fiber in the sky if you cannot lay it down underground. So how the system works, we have the space segment. We are going to launch 600 plus satellites in the low Earth orbit. As we said, it's a high volume satellites production, low cost per satellites. And then we have the ground segment, which is more than 40 ground segments or gateways around the globe. And we have the UTs at the user premises. It is most of them are very convenient and easy to install. It doesn't require a technician to configure or to point. It's just like plug and play. And we have our operation centers in London and Virginia. The spectrum we use is, as we said, the KU band and the KA band. So the KU band for the service link between the satellite and the user terminal, it is KU band, a 500 megahertz in the uplink, a 500 megahertz of uplink frequencies, and that's from 14 to 14.5 gigahertz. And then we have 2 gigahertz of downlink, and that's between 10.7 to 12.7 gigahertz. In the KA band, we use the KA band for the feeder links. So that's the link between the satellite and the gateway, the ground station. And we use 2 gigahertz of uplink, and that's between 18 to and that's between 27.5 to 30 gigahertz. So of a total of 2 gigahertz in this band, and then like 1.3 gigahertz in the KA downlink between 18 to 19 gigahertz. So the user terminal is very compact. We have different user terminals, as we will see in the presentation, but the very compact one is like we call a briefcase or a pizza box user terminal. It's like 30 by 60 centimeters by 8 centimeter thickness, plug and play. Everything is inside the antenna, the circuits, the electronics, everything is inside. You just put it in the view of the sky at the top of your building, your office, or your house. And then the gateway is 3.4 meter for each earth station. So our gateways contains several antennas. So from few antennas, like 10 antennas until 29 antennas. It depends on the location in the ground. So this is a video that shows how the system works. I'll leave it with you to see. It's a very interesting video which shows how the data flow goes from the user terminal to the satellite, to the ground station, to the POP, and eventually providing end-to-end connectivity.
Since the beginning, the World Wide Web has never been worldwide. But in 2021, a new and truly global 5G-ready network will fix that. Say you're working on the edge of the world and need to do a video call. Perhaps you're mid-ocean or mid-air. Wherever you are, you'll have a signal. OneWeb will connect your device through a customized terminal that can be as small as a briefcase and just as compact. Whatever your location, the terminal encrypts your data and sends it at high speed to our satellite fleet passing overhead. These spacecraft are radically innovative, built in our own factory at 1/50th the traditional time and cost, shrunk to the size of a washing machine, yet engineered to deliver powerful throughput. Month by month, we're growing our satellite fleet, and by 2021, we'll have not only the global spectrum rights, but the network reach to deliver truly worldwide coverage. And here's the revolutionary part. The fleet will be in low Earth orbit, 30 times closer to Earth than geostationary satellites. This gives you a stable, real-time connection with no interruption or annoying lag. What's more, our fleet always keeps moving, orbiting in a constellation design that creates seamless coverage. Each satellite uses a set of beams to cover an area the size of Alaska. Terrain is no obstacle. From its flight path and pattern, our fleet can always find your signal, so we can get you online from even the trickiest locations, with look angles that geo-satellite broadband simply can't deliver. We maintain high-grade system resilience from 2 ops centers using state-of-the-art ops concepts. Cloud architecture gives us powerful scalability and control remotely. For example, we can remove satellites at the end of their service life, so that the only trace we'll leave in space is on your screen right now. Now back to that video call of yours. We beam your data back down to Earth to our nearest satellite network portal. Then via one of our point of presence gateways, positioned in secure locations trusted by global providers, it re-enters the web. The journey you've just watched takes, at most, 1/10 of a second. And there they are. Your video call is good to start, whether with colleagues or your family back home. So from 2021, you need never be out of signal or out of mind. OneWeb will connect you from unconnectable locations and keep you productive on the move. It'll be a breakthrough year when OneWeb technology creates real human progress, connecting everywhere, for everyone.
All right, so the space station is our satellite. Those more than 100 satellites we are going to launch. Each one includes 16 beams. We call it a strip beam. Each strip beam covers on the ground 1,600 kilometers by 1,000 kilometer coverage on the ground. So 16 strip beams, and then each beam is 65 kilometers. So by 16 is around 1,000 kilometer on the ground footprint. We have 600 of them. Each one is 150 kilogram weight. It's like a dishwasher size. We are now at a 1 per day manufacturing rate, and eventually we will reach 2 per day manufacturing rate. And by the way, there was a well-known program series called Made in a Day by National Geographic. If you can search for it and see this very short episode about how OneWeb satellite is manufactured in our Florida factory in 1 day. So this is a picture of our second launch, I believe. Those are 34 satellites, all in one launch, and those are ready just to be put on the rocket and inside the fairing for the launch. So going forward, we will have between 34 to 36 satellites in each launch. And those satellites are mostly automated production. So this is an animation of our real videos of our factory in Florida. So for example, the screwdriver, the torque of it is calculated for each screwdriver. The automation, the testing of the system, all done in the factory. And that's in 1 day. How amazing the technology advancement is these days. So, and those are some of the pictures for our satellite factory in Florida. And this is the ground station. The ground station, as we said, it has many antennas. So that particular picture is in Svalbard, at the very north of the Earth, near the pole. and this is very important for connectivity. So we will have like 29 antenna in this site to provide this connectivity. The more satellites you have flying over the gateway location, the more antennas on the ground you need. And that's because our system is a polar orbit. We have 12 planes. Each plane has many satellites, and the Earth on the equator, those planes are far from each other. And when you go to the north or to the south, those planes will become closer to each other. And that means more satellites flying over the location of the gateway. And that's why you need so many antennas in the north and the south, and fewer antennas around the equator. And those are our type of antennas. We will have a dual parabolic antenna, and that's a capable antenna which can provide up to 400 megabit per second downlink and a 30 megabit per second uplink. Those are dual parabolic, so you will have two of them, and that's because one of them will manufacture the satellites which are flying over you, and the other one will be waiting for the other satellites to rise from the horizon to pick it up, because this first terminal cannot go back in 0 time to pick the satellite. So for continuous services, you will have two of them. So one is tracking like this, one is waiting. When it's picked the satellite up, it will track it, and the other one will come back. I hope I have a video to demonstrate this this communication, but I'm sure we will have in the near future. The second type of the antenna is what we call electronically scanned antenna, and that's fully automated. It does not have a real antenna or a mechanically moved antenna. It's all electronic. It's just to track the satellite, and it uses a technology called a beam forming technology. So it tracks the satellites and doesn't need to be let's say it does not need a technician or a pointing in order to fix. It's almost plug and play antenna. And then the latest terminal, which is still under development, by the way, is an active electronically scanned antenna, and that will be used for the mobile applications. I believe it will need a few years before we will have this antenna ready. But that's just to give an idea about user terminals, which is really very important in the satellite network as well. Without antennas, you never be connected to the satellite network, of course. And at the end, I would like to speak about responsible space. So OneWeb is very cautious and very interested in this topic. Our chairman and founder, Greg Weiler, says, on my tombstone, it should say, connected the world, not created orbital debris. And that's very important for the many mega constellations which is proposed these days, with thousands and thousands satellites. So we only have one space. If we keep filling it up with debris, we will end up with a very debris crowded shell above our beloved Earth, and then neither the satellite will work, neither we can explore our universe if we continue like this. So OneWeb is deeply concerned about this topic. We participate actively with government and with regulatory agencies to help them form their regulations and policies. The latest, for example, is what we are doing with FCC, the Federal Communication Commission in the USA, for their debris regulations. And from a technical point of view, we have invested a lot in a technology called grappling hook innovation, which is a small, tiny magnet piece sticked in our satellites, as you can see in those 3 pictures, that will allow in the future shall the technology permit to grab the satellite for services and for deorbiting. I'm not sure if this video would work. Yeah, so this is the technology and how it works. So we have fixed those fixtures on the satellite. So all of our satellites will have this equipment. It's an innovation. It's an innovative and an innovative design that will allow satellite service in the future and satellite deorbiting. So it comes in different shapes, but ours is a magnet capture as shown here in the video. So this is my last slide. I would always love to present our initiative to connect schools. So when we launched our first 6 satellites, we have the honor to visit 6 schools worldwide, in Nepal, in Kyrgyzstan, in Alaska, in Rwanda, in Ecuador, and in Honduras. We visited the schools. We have gave them a presentation of our satellites and a very simple lessons about how the satellite works. The kids are super interested in the topic and they are very excited. We have kept connection with them, and we actually named our first 6 satellites after those schools worldwide. So connecting schools is one of our important missions. So this is all of me. I hope I'm on time. Thank you so much for hosting me, and I remain available for any question. Thank you so much.